Okay, let's take a trip down memory lane here. So, how did we do this way back in the day? Here we go. Before that.
You cancel stuff out.
Yeah, you guys remember how we reduced like this?
Yes.
So,
That means we have to do the same
you
thing.
can divide and this. So it's pretty much the same as yesterday. So, yesterday we were like, in one fraction you can like divide the top and bottom by 2. But when you multiply two fractions together, you can reduce those numerators to denominators. So, in other words, it's pretty much the same thing. So anything on top, if you're multiplying together, can reduce with anything on bottom. Just like reducing in one fraction. So yesterday's was like this, where we reduced, divided top and bottom. Today's is like this, where we're going to reduce, divide top and bottom. So it's very similar, kind of a repeat. So just think of it as more practice. But they are bigger because we have two fractions now instead of one. So, number 1, here we go. 9y over x times x over y squared. What can I reduce? X and one of the y's. So,
isn't that x supposed to be an x squared?
oh, was it? Yeah, you're right. So, okay. Yeah. So 1x cancels out, that leaves an x on the bottom. 1y cancels out, that's going to leave a y on the bottom. So what do I have on top? 6. What do I have on bottom? xy. See? So easy. So easy. Lady, you look like you're not believing me. No comment? Do you want to do the next one? Is that what you were?
She's really amused by that.
That was more for me than for her. Okay, 5a cubed. I don't want to write all this stuff. These are too big.
We don't want to write them either. Maybe we should just skip this.
I didn't say you had to write them. I'm just writing them so I can like talk about them. All right. Should we go around the horn? Luke, you know something that cancels out on this one? We got lots of options here.
Well, you could use 2.
2 with what?
10 and 6. Or the A.
Okay, we could reduce the 2 and the 6. We could reduce the 10 and the 6. Yeah, all those. So I'm going to go 2 and 6. If I divide those by 2, become 3 and 1. If I have a 1 down there, I don't really need to write it, but because 1 times whatever is whatever, so it kind of disappears. What else? Ty, what else we got? What else cancels out?
A squared.
Okay, on top, I have A3 times A4, which is what? A7 divided by A2. What's A7 divided by A2? A5. So basically, yeah, actually here I'm just going to write it like this. A2 and A3 cancel out, but that leaves one A on top. But over here I have 4 more, so eventually we'll have 5. But for now, we'll come back to that later. 5 and 10 reduce, right? Divide by 5, that's 2 and 1. I'm just going to put the 2. And on the B's, how many do I have on bottom? 6. How many do I have on top? 6. So they will all just go away. Basically everything on bottom is together. Everything on top is together. All these things are 1. All these things are 1. So what do I have left on top? I see a 3. I see, how many A's do we have? a to the fifth. What do I have on bottom? Not much, just a 2. Number 5, okay. Alright, this one looks really big. I kind of feel like in a way it's easier because there's less things to look at. What changed from 3 to 5? Number 3, there's just one term in the numerator and denominator. And on number 5, there are multiple terms, polynomials. So, what can I reduce? It's kind of a trick question. Can these x squareds cancel out? No. Okay, remember yesterday when we talked about this? Do these x's cancel out? No. When there's a plus right there, you need to think of that as one thing. Okay, because, yeah, I'm not going to try to explain it, but division and addition are not opposites, so they don't cancel out, basically. So when there's a plus or minus, you got to think of these as one thing. So I can't really cancel any of this stuff out, but what can I do, though? Factor. If I factor it and turn it into these guys, then those factors could cancel out. Like, okay, what goes into 18 that adds up to 9? What multiplies into 18? 3 and 6, 9 and 2, but that adds up to 9 would be 3 and 6. So the top becomes x plus 3, x plus 6. By the way, you do need to write, you don't have, I don't care if you copy the problem down, that's just kind of busy work, but I do want you to show your work like this. The x plus 3, x plus 6 thing. Okay, and then on the bottom, what multiplies into 6, positive 6, that adds up to positive 5. 3 and 2. So that might trick some people because they might say 6 and 1, but 6 minus 1 does not multiply to positive 6. You have to use 3 and 2. Whoops. What multiplies into 4 that adds up to 4? 2 and 2. So x plus 2, x plus 2. Okay, and what was this thing called? Square minus square, difference of squares, the book might call it. So, you take the square root. What's the square root of x squared? X. What's the square root of 36? 6. You do x plus 6, x minus 6, one of each. That's the hard part, and the easy part is crossing stuff out. So what crosses out? I see an x plus 2 right there. What else? X plus 3. Anything on top, anything on bottom. It's all together.
X plus 6.
X plus 6. So all we're left with is x plus 2 over x minus 6. Multiplies into 15, into negative 15. That adds up to 2. Crystal, what multiplies into 15?
3 and 5.
And how do I get a 2 out of that for adding? subtracting.
-3 and 5.
Yeah, 5 and -3, -3 and 5, yeah, either or, it doesn't matter. Okay. What multiplies into 9 that can add up to -6? Only 9 times 1 or 3 times 3, right? Which adds up to -6? If we use two negatives. -3 times -3 also equals 9, right? So it's -3, -3. What multiplies into -18 that adds up to 3?
6 and -3.
6 and -3. And the last one, what multiplies into 30? 5 and 6, right? Does that add up to 11? Yeah, it does. Alright, and now we go crazy. A plus 5, A plus 5, A minus 3, A minus 3. What did I miss? I feel like Vanna White here. One, yeah, nothing, if nothing's left, you got 1 left.
You don't look like that.
A little bit hairier arms, maybe.
Just slightly.
Okay, also back to middle school, how do we divide fractions?
Flip the second one and multiply.
Oh, you've been tutoring, haven't you? Yeah, you flip the second one and multiply. So the bottom section is just like the top section, except for the right fraction needs to be flipped. That's the moral of the story. So on number 9, I'm not going to write it down like they wrote it down. I'm going to put 4a over 5 times 5 over a. So I just flipped the second one. Okay, what cancels out? This is an easy peasy one. 5, a. What's that equal? 4.
I can't see, so just like clarify that.
Can't see through my head.
No.
Okay, I'll block it on the next one. No. You guys could sit in the middle. Nobody's here. So on 11, I'm going to flip the second one and put 5x minus 10 on top, 4x squared on bottom. Okay. What can I do to this top numerator on the left? Is it a square minus a square? Is it 3 term? No. What is it? Take stuff out. What comes out of both of these? 2. What's left if I take a 2 out of both of these? Okay. The bottom, the denominator, this is too simple to do anything to. So it's just staying x minus 2. Can I do anything to the top right? Take out a 5. And what's left if I divide those by 5? Minus 2. Okay, now what cancels out? Couple things I see. X minus 2. One more thing. 2 and 4 reduce to 1 and 2. I'll put a 2 down there. I think I got everything, didn't I? So on the top we have 5 times x plus 3, which we are not going to multiply together. We're going to leave it factored. And on the bottom we have 2x squared. Did I get the line on that one? Kind of forgot. Because 13. Maybe I'm not gonna write all this down, it'll take me too long. A squared minus 4. How do we factor that guy? Yeah, square minus a square. The roots are a and 2. So you just do one with an a minus 2 and one with an a plus 2. The order does not matter. Okay, the bottom left denominator. What multiplies into 6 that could add up to -5? 2 and 3 multiply into 6, and if you make them both negative, they would add up to -5. Okay. So I'm flipping the right one, right? So I'm going to do the bottom right first. What multiplies into 14 that adds up to 9? 7 and 2. Multiplies to 14, adds up to 9. And then, so the top right is on the bottom. So what multiplies into 4 that adds up to 4? 2 and 2. And then we go wild. A plus 2, A plus 2, A plus 2, A plus 2, A minus 2, A minus 2. So I'm left with A plus 7 over A minus 3.
We should just go to 16.
Should we? Is that what you
You
feel in
have
your heart?
to flip the page to do 17 and 18.
Yeah, that's in.
And it starts a whole new section.
That's a tough point to cross, you guys bear. 18. I thought we were making really good time.
No.
You don't think so?
That clock's wrong.
Uh-oh. We're getting in muddy waters now. Okay, on 5a squared minus 5b squared, what can I do to it? Take out a 5. If I take out a 5, whoops. You guys gonna call me on that stuff? I'm gonna be left with a squared minus b squared. Does that ring a bell for anybody? It's a square minus a square, right? So, yeah, a and b, a plus b, a minus b. A square, maybe I should stop and redefine that, is something squared. So a squared is a square, but also 9 is a square number because it's 3 squared. Or 25 is a square because it's 5 squared. So a squared is square, but also 9 and 25. Anyway, alright, that's the top left. Lost my place. A plus b is on the bottom, that's good, we don't have to do anything to that. It's too simple to do anything. Oh darn. And then the bottom right, 3a plus 3b, what can I do to that? Take out the 3. So I just have 3. A plus b. And then the top right, which is going to go down. Okay. It's 3 term, right? A and A go in front. So what multiplies into 1b squared? What multiplies into 1b squared that adds up to -2? What times what equals 1 that adds up to -2? -1. Okay, but since it's b squared at the end, we can't just put -1, we gotta put -1b, -1b. Or just minus b. What cancels out? One of the a plus b pairs, one of the a minus b pairs. Does a plus b and a minus b cancel out? No, they don't. They're not the same. So what do I have on top? 15, a plus b. Yeah, we can multiply those together. 5 times 3, 15. A plus b. And on the bottom, I just have a minus b. If all you got on the bottom is a minus b, you don't really need parentheses anymore. So you guys want to do 17, huh?
No.
See, it's not good.
No, I was looking at 25. I just realized we probably should have done some of those. You guys want to go above and beyond 25?
No,
Oh,
I like to be
you
better.
struggle with
All right, how about this? So we'll compromise and do 25 and 26 instead of 17 and 18. That's probably a good idea.
That's acceptable.
Okay, yeah, I'm gonna do that. We'll do 25 and 26 in lieu of 17 and 18. There's an expression you don't hear now. Man, that looks confusing, don't it? Like my English?
Yeah, I did.
Pretty impressive. Can anybody tell what's going on here?
Yeah.
Okay, it looks more complicated than it is. That's why I wanted to make sure we looked at it. Okay. This is how the book wrote it, all this business over here. This is another way we could have written it. So really it's the same kind of, you guys see what's going on here? It's just this divided by this. So what needs to happen?
Flip it.
Flip this guy, and then it's just like all the other problems. So here's another way to look at it. You're dividing by this guy, so I'm just gonna flip it and put it up like that. So it's just times 10x over x plus 1. So it just looks weird, it's not actually that bad. Alright, let's get rid of that. What can I do with x squared minus 1? What's going on there? Squared minus the square. Do you guys know 1 was a square? 1 squared is 1, right? So what are the square roots of these? X and 1. So that factors to x plus 1, x minus 1. Here, we don't miss that. They were nice to us on this one. Can I do anything to 10x? No, it's just one term. Can I do anything to x plus 1? No. There's nothing we can take out. It's not a square minus a square. No. So what cancels out on this one? Okay. 5x and 10x. The x's cancel out. The 10 and 5 become a 2. And the x plus 1s. So all we have is 2 x minus 1. Yucky. Try again. 26 does look a little bit different. You guys know how we're going to set that one up?
5x over 1 is basically.
Yeah, you can think of it as 5x over 1 divided by 3x over x minus 3. So it's 5x over 1 times x minus 3 over 3x.